Hello, all my JavaScript friends. This is the Virtuoid, aka Mike Smith, and this is our racing game. As promised, this is our video that deals exclusively with the car and nothing else. Mostly because the car has been a major issue in trying to get working. We actually, with the original version, we actually got it working without any kind of problems. But with the new physics here, while we pretty much eliminated almost all of our problems with the tracks, we've introduced more problems with the cars. But we will get to that as we go along. So I kind of want to take you in on a little bit more details about how the car was constructed. If you're following along, the repo is available to you, Fun With JavaScript-public, and you can go to the car box. Let me just highlight that here real quick. You can go to the racing game underneath the Fun With JavaScript public. You can go to the racing game itself, and then within the racing game there is a car box, and the URL is the localhost /carbox/index.html, and that will get you what you're seeing here on the screen. Well, now what you're seeing here on the screen, and this allows me to kind of play with the cars and make sure everything is working. So let's go through quickly about some of the different pieces of the car. Now, as you can tell here, we've got a car on the screen. Let me just actually zoom in just a little bit. We got a car up on the screen. This is the Ferrari model. And we've got some weird things down there at the bottom. Don't worry too much about that, because I kind of want to show you the different pieces that we'll be working with on the car. The first piece we have to work with is the wheel. The wheels, well, the four wheels. The four wheels are attached to a chassis. And the chassis, and then the model itself, which you should see in the large red thing here, is attached to the chassis itself. The model also doubles as what we call a collision mesh, and the collision mesh will encompass the entire size of the model itself to help us determine where a collision occurs with the particular model. And that's actually the collision mesh is where I'm having some difficulties with. Now, if we were to, once we really get everything working, get the model working, collision mesh and everything working like that, what we would actually do is disappear the wheels and on the model and disappear the wheels that you see right here and replace the wheels on the model with the wheels inside the chassis. In fact, I forgot. Let me show you the chassis. I'm going to go underneath the ground and go up a little bit here. You can see that white line underneath here, underneath the model. That is the chassis. So the wheels are connected to the chassis. The model, it's also connected to the chassis, and the invisible collision mesh is also connected to the chassis. So that's basically all there really is to the car itself. So let's now dive a little bit deeper into it. What I'm going to do is I'm going to go into the code, and I am going to turn off the model so that we can get a better chance to see the different pieces as they work together. So this is the actual car without the model. This is the wheels and the chassis. These are the most important things to it. If you remember on the other previous videos that we have done, when we crossed the finish line, it was always the chassis that I told it to take a look at when we crossed the finish lines. In reality, once we had the collision mesh on, the collision mesh would be the size of the model. That would be what gets checked, that goes across the finish line. But for right now, just for testing purposes, it's the chassis, or this white bar that we are checking. So let's now just dive into the code and see what we can take a look at. This is under, if you go into car box, the car.js is the car that I'm using. And one thing to warn you, if you're going to be following along at home, is that I have got a ton of debugging stuff floating around inside this car and a ton of testing software. So we're talking about 518 lines. In reality, it's not 518 lines. It's a lot shorter than that, but I've got a lot of testing in there to try to figure out what's going on. But basically, everything runs in a particular order. Like I said, we have the chassis and we have the four wheels, and so we're going to be creating the chassis physics, the wheel physics. We're going to build the wheel base. This is the base of the wheel itself. I cloned the wheel 4 times to get all the different wheels. This is the material and the checkerboard that you see on the wheel. I didn't have a wheel available to me, so I just went ahead and used the checkerboard just for fun of it. That same thing I used for the finish line, and but it was enough for me to be able to tell that it turns. And again, this was just a testing possibility. And here's where I just made a quick little adjustment to the scaling, and blah 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 blah. All that is not relevant to this. The build section is what's relevant. This is what builds the entire car out. And what will happen is that once we do build it all out, let's go back to the very top here. Once we build it all out, oh, okay, I messed up there. We go back to the app. On the app itself, once we build it all out, the app is where we added the cameras and the lightings and the physics and all that kind of fun stuff. So once we build out the car itself, then we then we do the where's the scene there? There it is. The render. Then we do the render loop, and that's where we there it is. I couldn't find it. That's where we render the scene itself. So if you're familiar with the other programs, after we built everything, in this case the canvas, the engine, the scene, and then we build the car, and then we render it. So that's no big deal. So now we're just going to just take a look at the car itself. So build in this case is where we're going to do the physical building. This is the only one that I don't use the word render with. I should, and I probably once I get everything working, I probably will refactor this one to say render instead of build. But here you can see where I've been working with a ton of different things, but I got everything split into different pieces so I could take them one at a time. And that will allow me to kind of just make sure everything is working correctly. So basically the idea here is we'll build the chassis, and that's that square box in the middle. And then we'll build out all the wheels. That's the 4 wheels. Then we'll assign parents. So there's a certain order in which I want to make sure that the parents are assigned to the parents. The wheels are parent of this particular mesh, and another mesh is parent of, and the chassis is a parent of another mesh. Then we by default build the chassis physics aggregate, then the wheels physics aggregate, and then the constraints. The constraints is going to be the really important thing. That's what binds everything together. So what we're going to do here is we're going to just take these one step at a time. Oops, I'm going to keep that on. So we're going to comment out everything here with the exception of just building the chassis. So let's take a quick look at that. Build chassis. There we go. So in the build chassis, it's extraordinarily easy. I am doing a new standard material. Notice I'm not using the UI option yet, because again, I'm just experimenting, trying to figure out what the heck is going on here. So I'm going straight to Babylon.js. I'm creating the box. This is the chassis box itself. And then I'm creating the material, which happens just to be a simple little white color to it. And so once we've done all of that, let me go back to the screen. Let's F5. Let's F5 the screen. There's the chassis, and I've positioned it originally very high. Once we assign parents and everything, that everything will be rotated correctly. But that's the chassis. I mean, there's really nothing to it. It's got weight to it. It doesn't roll. It doesn't do anything. I don't know. That's really all there is to it. The chassis was the square thing. We also do the chassis aggregate. Let's see if I can find it. Yeah, chassis aggregates. Where the heck is it? Set wheel constraint. There we go. Chassis physics aggregate. This is where we assign the physics aggregate to the chassis. And one of the important things here is this section right here, the filter membership mask and the filter collide mask. This tells us what group this set of meshes belongs to. So all the wheels, all the collision mesh, and all of the chassis will have the same membership mask. And their collide mask basically that basically says what membership group are you associated with. In this case, it is built upon a bit mask. So the first group may be have a value of 2, the next group may have a value of 4, the next one would have 8, next one was 16, 32, 64, 256, so on and so forth. And it'd be 128, 256. But anyway, so the idea here is that everybody will have a different membership, so that the wheels, if they will not collide with the chassis will not collide with the collision mask, and so on and so forth. And the collide mask within each of the meshes tells us which other meshes we're going to collide with. And so basically the collide mask is an opposite of the membership mask. And so that will allow us to basically say, you can collide with everything on the board except for the people in your own membership. And that, of course, basically will mean, hey, I'm a wheel, I'm connected to this chassis, I'm not going to collide with you, and so on and so forth. I'm not 100% sure that is exactly correct, and maybe one of the problems I'm having with the collider mask that I'm working with, or the collider mesh. But we will work on that. But that's all there really is to the build classic. That's all there really is to the chassis itself. Now what we're going to do here also is we're going to set the parents to get it looking a little bit more noteworthy, because I have a parent. Here we go. I have a parent that I build, and when I build the parent, this parent mesh, everything connects up to this parent mesh. So hopefully the parent mesh kind of just controls everything. And again, this may be incorrect, so let's go to assign parents, because I think the assigned parents also has the wheels in there, and I don't want the wheels to. Collision body, chassis parent. Okay, yeah, we're in good shape. Okay, good. So if we get the parent in there and we go back to our screen, you can tell it's already flattened. So let's just press F5. And now, since the parent was positioned just above the ground, it just barely flops onto the ground. But now it's kind of oriented the way we want it oriented. So we've assigned the chassis to a parent mesh, and that parent mesh is basically going to be the car, for lack of a better term. And again, that may be one of the issues I'm having with the collision body. I don't know. That's one of the things we're going to work with. So that is the collision mesh. Let's take a look at the wheels themselves. Wheels are very interesting. The first thing we're going to do before we do anything else is to build a wheel base. And the wheel base is the base of the wheel itself. It is the base of the wheel itself. It is completely invisible, and because of that, we are always going to take this wheel base, and it will not be part of the physics, but it will be cloned each and every for all the 4 different wheels, and then the physics apply to those 4 wheels. And I just suddenly realized, I'm wondering if this might be my problem with the collision body. But again, we'll get to that a bit later. Why am I creating a capsule? It was very interesting. I found it very difficult to create a sphere, for example, and get it to work nicely with the chassis, and get it to work with the chassis, and to get it to actually look pretty good. You can take a sphere and give it different diameters along both the X and Y axes, and so it kind of made it look like a rounded tire. It didn't, and that's what we used in the original version of this game about 2 years ago. It looked okay. One suggestion I saw online, in fact, where I got the original idea for how the constraints work, which we'll get here in just a minute, used a cylinder that was flattened down, and that works pretty good. But even that just didn't work very well with what I had here. But for some reason, the capsule worked great, and by having this strange height and the strange radius to the capsule, what we end up with is a funky looking wheel, but it works beautifully with the car. I just got to be able to skin it and to make it look correct. So the wheelbase gets built out, and once the wheelbase gets built out, when we build the wheels, we just build all 4 wheels straight down. And it's no big deal. All we do, we clone off the wheel, we give it a new ID, we set the position of it based upon the wheel type: back wheel, back right, front left, front right. We set the parent to the chassis. This is where I did realize the parent of the wheels need to be the chassis. We make them true, and we give it the material, which is that checkerboard square, and then we set the wheels. So once the wheels get set, then they get attached to the chassis. So let's go back up to our build, and we're just going to build the wheels. I'm not going to do anything else but build the wheels, which means they're going to still be they're going to be parents of the chassis, but they're not going to be they're going to be children of the chassis, but they're not going to have any kind of physics. So this is going to look pretty weird, but you'll get to see what the wheels look like. So let's go to the screen. There are the wheels. Look, they're kind of embedded to the ground because they have no physics on them whatsoever, but they didn't go anywhere because they're connected to the chassis, and the chassis stopped moving once it hit the ground. So for instance, if I want to now, you want to see something really kind of funky weird. If I go now back over here, and let's go into our app, and what I'm going to do in the app is on the ground. Where did I put it? Was it on the app? There's nothing worse than suddenly forgetting where you put. There it is, ground physics. I'm gonna rotate this thing a little bit. Negative is what I want here. I'm gonna rotate this thing a little bit to see if it moves. So let's go back to our screen. Now notice my ground is rotated a little bit. Since there's no friction on the ground or on the chassis, everybody moves. But notice that the wheels are going straight through everything. They go straight through the walls, they go straight through the ground, because the only thing that's been physically enabled is the chassis itself. So there we go. So let's now go back over to our code and into the car. And now we're going to assign, we got the parents assigned, now we're going to build the wheels, the wheel physics aggregate. And this is going to apply physics to the wheel. The wheels are still going to be attached to the chassis, but they're not going to be constrained anyway. They're just going to be flopping around. So let's go back to our screen. And there they go. But notice now, although they are parents, everybody has their own physics now. So even though the chassis is the parent of the wheels, because they have their own physics now, are completely independent of the chassis. So you end up with things like this happening. These are pretty cool. I like these wheels. I think the cylinder really came out really nice for the wheels. Kind of looks like a rim is what it looks like. So they really came out really nice, but I'll have to get better graphics for them. But that's so we've added the physics to the wheels, but of course there's nothing that's connecting the wheels up to the chassis. There's nothing physically from a physics point of view connecting to the chassis, and that's where what we call the constraints are coming in. Now this is something it took me for flipping ever to try to figure out how to get it to work, and I finally found the website that had it somewhat working. In fact, it's the one that did the cylinder wheels, and I had to make a few tweaks here and there to get it to work correctly. But the idea here is that when we do a constraint, a constraint is basically tells the physics engine how two meshes are related to each other, and how actions between one or the other will constrain one or the other. For instance, a opening door, a hinge, for example, you'll have a mesh of the door frame and a mesh of the door, and you will be able to tell, hey, I've got these two are connected to each other, but it's only allowed to rotate along a certain axis, along a certain axis, and that will give you some sort of hinge effect. In my particular instance here, with what we call the wheel constraint, I am setting what's called a 6 degrees of freedom constraint. And this is where I can set a axis. I can set a different pivot axis. I can set up a different revolution axis and a perpendicular. I think it was called a perpendicular axis, all through here, to be able to sit here and say, okay, this is how this wheel is going to function. Basically, what this idea here is. And again, this is how I understand it. This is something I'm still studying, trying to figure out how it works. This pivot A and pivot B allows me to be able to say where the pivot point between the two meshes is going to be. And in this case, we have wheels, and the wheels are on the right front, right back, and left back. So I'm making the pivots for the wheels to be for the wheel for pivot A being the chassis. it's going to the point where everything pivots is going to be at this particular position on the chassis, and where it pivots on the wheel is going to be at this particular position on the wheel itself. This is the axis in which it's going to spin. In this particular case, both of them are going to be on the x-axis. And so by having it on the x-axis here, we're basically going to be confining the y-axis to spin, and where it won't spin, and we're going to confine the z-axis to where it won't spin, because we've got a wheel here, so we just want it to spin along one particular axis. In this case, it's going to be the x-axis. The perpendicular axis, I'm sorry to admit, I have no clue exactly what that means, but 0, 1, 0 worked, so I kept it at that. Now, here's the key here, the different limits that we're going to have here. We have limits on the x, the y, and we have linear limits on the x, y, and z axis. And on the x and y axis, we have angular limits. Again, I'm not 100% sure exactly what these do too. I'm sorry to say the Babylon JS documentation on this is poor. And it might be because they want you to use the Havoc physics, because Babylon JS uses Havoc physics plugin. So I probably need to go dive into the Havoc physics to figure out exactly how this works. But this particular sequence of constraints will physically connect up a wheel to a chassis, and this is the line that does it. This basically says I need to go I'm getting the chassis, the body of the chassis, and I'm adding the constraint I'm adding the constraint from the wheel using the constraint that I've just defined here on line 462. By doing that, that basically then makes a physical connection between the chassis and the wheel, and basically say if the chassis does one thing, it's going to affect the wheel. The wheel does one thing, it's going to affect the chassis. So now, where before, as you saw, the wheels had their physics, the chassis had its physics, and none of the twain should meet. Now we're basically hooking them together. And once we have done that, then we can come back and put all four of them onto the chassis. As soon as I can get up to the code, here we go. And by doing that, that is going to be the wheel constraints. And once that is done, then this is what we get. So now everybody is affecting everybody else. The wheels still spin as they normally do. They still interact with the wall as they normally do, as does the constraint. But as soon as the wheels hit something, it's going to, because the constraint is there, it's going to communicate to the to the chassis that it needs to also stop, so the chassis stops. And vice versa, if the chassis happens to hit something, which it won't in this case because the chassis is fully encased within the wheels, then it will obviously have to do, it will obviously tell the wheels to stop at that point. And the wheels only spin, let's just F5 this again, and the wheels, because we are dipping down, the wheels are spinning real nice and pretty, and they just go quietly on their way, spinning down. So by having the cylinder there, though, what I've discovered, let's go into the app. Let's go back to our code here. I'm going to put the rotational axis down to the z-axis. Let's go back to the screen. Now the z-axis, as you can tell now, is now kind of, you can see it's kind of tilted toward the camera. But notice it's not moving. It's not moving because there is some definite resistance. It rolls real nice and pretty and even going forward because that's the way the wheels are built. But because we have that hard edge there on each of these wheels here, we're not sliding down. So it does work to an extent. Let's go back to let's make it a nice big rotation. See, still even sticks there. That's good. Let's increase the rotation even more. Good. Even more. Good. I say, so this is really good. So as you can tell here, it's really just hanging there. I don't think it's moving at all. So that's really, really, really good. So let's change that back to the x-axis. And there it goes. Ah! So one of the things I got to figure out in the game here is that if you notice, some of the cars would slide really well one way or the we slide on their side of one, very well, and that kind of bothers me. So I've got to try to figure out what I've done right here that I've not done on the car. But that's basically all there really is to it. The only thing that's missing here, and this is where the model comes in, is that we need some sort of collision body. And the collision body is supposed to, let me throw the model back on there. So let's go back to the car, and we have a build model. Let's throw the model back on there. So there's the model, and you'll notice here, let's let it slide on down. You'll notice that although the model is moving with the wheels, and it looks great from this point, there's no collision detection with the model. And it just goes oh, I wasn't on the screen. Let's try that again. All right. So you'll notice here as it's scrolling down here, the model is moving very nicely with the chassis. That's exactly what I want, except that once it gets to the wall, whoosh, it just goes straight through the wall because there's no physics associated with it. So what I've tried to do is, let's go back to the code here. Because the model is so large, I want to be able to, and it was difficult to try to figure out how the collision body worked. I wanted to try to get it as simple as possible. So I built physically what is called a collision body. And this is basically my test to be able to try to figure out how the collision body works. And if the collision body works, then the model should work too. So once we save that, we can go to this thing here. You can see the collision body is just right above it, and that actually works really well until I start to apply the physics to it. So if we were to go back to the collision body, we're going to put in the physics aggregate first before we do anything else, and notice it just kind of flops down, which is what it's supposed to, because again, I've just got the physics aggregate in there, so it's not really attached to anything. But now I'm going to run the constraint, and notice they're not colliding with each other because they're at the same membership, so they're not colliding with each other. However, once I put in the collision body constraint, and this constraint, by the way, let me just zip down here. I hope I can find it really quick. Set wheel constraint, collision body constraint. I've tried, first of all, what's called a lock constraint. That to me made a lot more sense. In fact, I think that's the one I'm still using at this particular point in time. Yeah, I'm using constraint there. Yeah, I'm using constraint. So the lock constraint is something that says I want to lock these two pieces together, and they just basically move together in tandem. That's exactly what I want to do. I want to lock the chassis and I want to lock the collision body together so that they don't move, so they move together completely without one or the other moving one way or the other, whatever. And that's what the lock constraint is supposed to do, and I thought I had it correctly. It didn't quite work, so I've even been working with the physics 6 degrees of freedom constraint to see if I can get it to do it that way. But when I add in the constraint, we get this. Whee! There it goes. Of course, this is incorrect. Now, once it hits the ground, in reality, it works fantastically. It's that initial whee! It's that initial fly up there, and I don't understand why it's doing it. But as you can tell here, this is exactly what I'm looking for. Once it hits the wall, boom. But you also notice there where it kind of moved a little bit with the constraint. I forgot about that. Yeah. So not only did it jump up, but it also moved a little bit. It kind of like had a little spring to it. And what I discovered is it all has to deal with the weights. Go back to the very top here. I've noticed here, this is if the chassis mass and the wheel mass are exactly the same, it works like a champ. Usually then if I wanted the collision body mass to be the same, it just goes all over the place. And so what I discovered is that if I was to go back and made the collision body mass, let's say even 0.01, I mean just barely there, you don't get that bounce. You get a little bit of the bounce at the very top. But you still get that. Do you see that? So I'm still trying to figure out if I can get this figured out, then I can apply the same principle to the model and then everything works perfectly. So this is what I am currently working on to try to figure out how that works with that. So once we get this all figured out, we're going to be in very good shape. So our very last video that we will be doing will be showing you the, hopefully I'll have the car fixed up by that point with the bodies and everything. We'll have some real races on there, and then we'll kind of go like we did with the jigsaw puzzle. We're going to go through a little post-mortem and say, this is what we need to fix, this is what we need to fix, this is what we need to fix. So this will end the this particular video. Thanks for watching. Subscribe to this channel to view more videos. Click on the like button on this video and visit us at TheVirtuoid.com. Also, support us on Patreon, where you can get access to member-only videos. Links are down below. Again, thank you very much for watching, and keep on coding.